Welcome to 5G Hub video tutorials. Today I will talk about 5G new radio RRC inactivity state. For first, I will talk about reasons for a new state model in 5G. As you know, RRC states are a solution to power saving and the mobility optimization in the different previous generation of 3G, 4G, and 5G. So reduce the signaling overhead on radio interface, network interfaces, poor interface will enable the user equipment power consumption similar to idle while improving the user equipment access latency. But what about the use cases? What we need to reduce the latency or the new state model for 5G? The use cases will be as below. The first one is mission critical user equipment or devices. These are the devices transmit small packets that require ultra low latency and high reliability. And for massive type machine communication, the devices will work up rarely power saving mode to transmit and receive a small payload, also camping in a low activity state, and transmits uplink data and or status reports with small payload to the network. Also are in connected mode, transmit uplink data with a small payload to the network. And finally, the smartphones and consumer devices, enhanced mobile broadband user equipment that have periodic uplink and or downlink small packets transmission and extreme data rates. So the state model for 5G, as you see here, will be the traditional idle state and connected state like 4G. But the difference here is the new state is called RRC connected inactive. So the discussions on RRC state machine design for 5G system have been discussed in 3GPP, and one of the objectives to reduce the control plane latency to lower the latency of the first packet transmission and achieve a seamless RRC state transition. So most of the solution proposed for a state model with 3 states: the traditional RRC idle mode and RRC connected mode states, and a new RAN controlled state. It's called RRC connected inactive. It's proposed that the behavior of user equipment in RRC inactive state can be configured based on the service requirement of user equipments with different requirements. So in this state, the transition from RRC idle to RRC connected will be expected to happen mainly during the first initial access when the user equipment attached to the network, or fallback case when devices and or network can't use the previously stored RAN context. Also, on the other hand, the transition from connected inactive to RRC connected are expected to happen often and should be optimized to be fast transition. So the objective to introduce the new state RRC inactive is to reduce the latency in the control plane and moving fast into RRC connected state. The user equipment needs more time from RRC idle to RRC connected state transition as compared to RRC inactive to RRC connected state transition. As a frequent transmission of a small packets is common for many smartphone applications, this results a significant amount of idle to active transitions. These transitions come at cost in terms of signaling load and associated delays. Therefore, to reduce the signaling load and in general to reduce the latency, a third state is defined, is called RRC inactive state. Okay, what about the key aspect for the RRC inactive state? There are different aspect keys, like user equipment context storage will be in RAM during inactive, like access stream user equipment context, security context is stored in user equipment and the RAM. Also, location tracking during RRC inactive is based on SIR selection, where user equipment may move within the configured area in RAN without notifying the network about a location. Also, allowing transition between user inactive and connected without involving any core networking. This will reduce the latency significantly. But what about the 5G state transition regarding or comparison to 4G state transition? A user equipment in RRC connected state or inactive state when an RRC connection has been established. So if this isn't the case, that no RRC connection is established, the user equipment will be disconnected or in idle mode, meaning that RRC inactive state is considered as a part of RRC connected. So here we can see some rows from RRC suspend, from RRC connected to RRC connected inactive, suspend, and RRC resume. These operations can be as below. RRC suspend. The user equipment will restore its radio configuration and security parameter when it transitions from connected to RRC inactive. Then when it needs to connect it to the network again, for example, due to some uplink data being available to transmit, for example, the user equipment will trigger the resume or RRC resume direction. So this procedure involves restoring the previous stored configuration and resuming the connection without the need for any signaling extensive with the core network or having to re-establish security, for example. And this is a comparison between LTE states and 5G states. Here we can see what is the difference between RRC state with inactivity state and without inactivity state. You will see with activity state the resume procedures, this resume procedures will reduce the number of RRC messages exchanged over the radio interface between user equipment and the RAN to 3, okay, down from 7 for the idle state. So the reduction in RRC signaling significantly lowers the access latency experienced by user equipment, which leads to more responsive end user service and the ability to support new cases. It also will reduce the power consumption for devices such as battery-powered sensors that only send small, infrequent reports or data less than 100 bytes of data. Finally, we can see the RRC state transition. The user equipment will enter into RRC inactive when RRC connection release is received with suspend config parameter. After reception of suspend config, the user equipment will store the access stream context like security configuration, PCI, cell identity of the source cell, and here user equipment will store the current RRC configuration. After that, the suspend all signaling radio pairs and indicate the suspension of RRC connection to upper layers. This is for 5G inactivity state in 5G new review. Thank you and hope to see you again in the next video tutorial. Thank you.